Well, for example, we can choose different elements on the line: 1 minus 2, 2 minus 4, minus a half, 1, half, minus 1. These are all vectors on the line L. And we see actually that these are all multiples of one and the same vector. Yeah, so we have x is t times a vector we will refer to as a direction vector of L. Yeah, d is 1 minus 2, yeah, which is on L. Yeah, you will calculate the inner product of n and x, which equals n times t times d, is t times n inner product with d equals 2, 1 inner product with 1 minus 2, which is 0. So all multiples are indeed on L, and in particular the above vectors we mentioned as an example. So in summary, we found actually two different descriptions of the same line. One is that the line consists of all vectors that are orthogonal to a vector we will call the normal vector of the line. And this is the n times x is equals 0 is a point normal equation of the line L through the origin. Well, the second one characterizes the line as all vectors x being a multiple of the same vector d, the direction vector. Well, this is called a parametric description of a line L through the origin. So now we're going to look at a different case where we don't have a line through the origin. So can we characterize a description of such a line? So we look at the line L, 2x plus y equals 5. Yeah, indicated by the blue line over here. And we take some vector x pointing at some point at L. Well, this line still has a normal or a perpendicular vector equaling to 1. Now take a vector p pointing at some arbitrary point of the blue line. Now p points at an arbitrary point on L. And look at the difference vector. The difference vector of x and p is on the blue line, and it is therefore perpendicular to the green vector n, which is given by 2, 1. So we have n in a product with the difference vector x and p, x minus p, equals 0. So that if we work this out, the inner product of n with x minus n, the product with p, equals 0, which is equivalent with stating that the inner product of the dot product of n with x equals the dot product of n with p. Now this will be called the general point normal equation for the line. So we see that we can make it by just choosing an arbitrary point P, so that we, instead of the 0 we had above, we now have n times P as on the right hand side of the equation.